Here's another example for all of you. Should be another fun one. I recommend pausing the video. Try to do it. Follow those steps. 1, 2, 3, 4, 5, 6, 7. Follow those steps and see if you can get there. Pause the video and let's go. All right. A company makes two products. Product A requires, let's be blue. Requires 3 hours. Oh, this is kind of similar. 3 hours of manufacturing and 1 hour assembly. 1 hour at. Yeah, great. Product B requires 4 hours manufacturing and 2 hours of assembly. Total of 84 total for manufacturing and 32 hours total assembly. All right, so determine the production to maximize profit. Okay, we want to maximize profit. If the profit on product A is $50, $50 per item, and product B is going to be $60 per item. All right, so first we have to decide what our variables are. Determine the production. What it wants us to find is the production. So how many of item A do we produce? How many of item B do we produce? That's the decision that's being made here. Okay, so you could let X and Y, you could let A and B, whatever you want. Let X equal number of product A produced. This is step 1. And Y be the number of product B produced. Great. Step 1. Step 2 is the constraint. We've already written down the constraint, right? Or the objective function right here. It's maximizing the profit. But we also have to do it in math. So first it's to do it in words, maximize the profit. And now if we do it in math, we're going to say maximize. P is our profit. We profit $50 for item A, $60 for item B. So 50 for every item A and $60 for every item B. Great, that's our objective function. That was step 2. Step 3, let's find the constraints. So we kind of did that a little bit. We only have a certain amount of manufacturing hours and a certain amount of assembly hours. So A takes 3 hours of so we'll have 1 for manufacturing and 1 constraint for assembly. So for manufacturing, product A takes 3 hours. Give me 3 hours of manufacturing for product A and 4 hours of manufacturing for product B. And we only have 84 total. We could use less than that, but we only have up to 84. Similarly, for assembly, A takes 1 hours and B takes 2. So 1x plus 2y, we only have 32 assembly hours total. And finally, we're not going to produce a negative number of these items. So we have our objective function. We have our constraints. We have our linear programming problem now. Okay. We're going to try to, Y, of course, takes more, but it takes double the amount. It makes more money. Y makes more money, product B. But product A, which is X here, takes half the assembly time and 3/4 of the manufacturing time. So we're going to graph our feasible region. This one actually is quite doable to do by hand. So you can do it either way. Let's do it by hand. Why not? Let's get some practice. All right, so if we graph the first equation, subtract 3x from both sides, you get 84 minus 3x, or y is less than or equal to 21 minus 3/4 x. And before I graph it, I want to see what the other one looks like. The other one will be 2y is less than or equal to 32 minus x, or y is less than or equal to 16 minus 1/2 x. All right. If we do this by hand, the first one, we're going to have to count Maybe count by 4s. So everything fits. Maybe 4 is too big of a number, but I want to make sure that everything fits. The blue line says start at 21, then go down 3. And since we scaled the same, I'm just going to count boxes. Down 3, right 4, and then we could also do not counting by boxes. We could count by units. So we're at 9 here for the y value. Down 3 is going to bring us to 6. Right 4 is going to be here. Down 3 is going to give us to 5. Down 3 from 6 is going to give us to 3. Right 4. This just helps us find our intercept a little bit better, which is going to be useful. But gosh, that is such a terrible, terrible line. I need a straight edge. I'll put my pen on my screen, see if it'll work. Not really. A little bit better. We'll solve the system by hand anyway. All right, and the other one is 16, our intercept, and down 1, right 2. All right, and that'll look something like this. And we'll have some point of intersection here. I don't know what this point is. We'll find this point by hand. Okay. But again, we need to be less than this blue line. We also need to be less than the red line. So that'll give us this highlighted area. And don't forget that there are 4 things that we need to check. The 4 corners of this area. So we know this one over here is 28, 0. We know this one up here is 0, 16. We know this one's here, 0, 0. We'll solve for this last point. Okay? And that's going to be when these 2 things are equal to each other. Or the method of addition might be a little easier here. If we look at the first equation and keep the first equation the same, and again, we're just solving the system of equations. We can forget about the inequalities for now. But if we multiply the second equation by -2, right, we're multiplying this equation by -2, then we can solve this system a little without fractions and just add them together. That's going to give us that x plus 0. Oh, this is really nice. X is 20. Great. And then there's a couple of ways that you can do it. We did already solve for y, so you could plug in an x equals 20 into one of these. That'd be fine. So y is going to be equal to 16 minus half of 20. Y is 6. This is the point 20, 6. So in other words, it's this point. Graphing by hand is unreliable unless you have a straight edge. Otherwise, you can solve it like I did. And now we look at these 4 points and remember that we're trying to maximize the profit. So make a table of our points, x, y, and our profits. We want to maximize these. So our points were 0, 0, 0, 16, 28, 0, and 20, 6. Let me just double check. Great. Plug each of these into our profit function. So $50 for 0 and $60 for 0, that's a profit of 0. That's not very good. 50 times 0 and 60 times 16. Right, that's going to be 960. 50 times 28. And 0 times the other thing. That's going to be, I should not, let's use a calculator. I'm going to need it for the last one anyway. 50 times 28. 1,400. If you have already discovered a mistake, just let me know. And last is 50 times 20 plus 60 times 6. That's going to be 1,360. All right, so our profit, is almost better here. But it's actually the best at the end again. Just like the earlier example we did. So this is our winner. So our maximum profit is $1,400. We should produce 28 item A's and no item B's. And again, if we had other constraints like, hey, you have to make one of each, well, then maybe it would be different. But with this problem, we're not making any of those assumptions. So we'll just be with that. Let me know if you have questions. Have a good one.